In this particular video, we will discuss about how to predict the location of a retinal break in a rhegmatogenous retinal detachment. So just looking back at the last video in which I had described how the retinal detachment progresses once you have a retinal break and a degenerated vitreous which allows eddy current formation and seepage of fluid into the subretinal space. So let's embark upon this, that if we have a detachment patient in front of us, how can we predict the location of a detachment? So let's make our standard diagram and make the optic disc, the blood vessels, and then see if we can make a detachment. So let's have an example. For example, we commonly see a situation where we have an inferior retinal detachment. So this is how a detachment is drawn on a fundus diagram. A blue shaded area and the attached retina is shaded red. So this is all we are familiar with. So now going by the rule that the detachment should have progressed symmetrically on all the sides, and because there is a horizontal level which we can see here, so we have a horizontal level here, and this will predict, if we simply retrace the progression which we had learned in the last talk, we can see that this must be pointing towards the concavity formed by this particular detachment contour. So if we can look at this, this is the concavity and this is where the break should lie. So this is one method which we can be of very useful use when you have a detachment which is subtotal, rather it is restricted to 1/2 or rather less than 1/2, maybe a quadrant or so. So we'll apply the same to another example. So if we have a detachment which is covering maybe this temporal quadrant, so again going by the rule that there are two issues here. One is progression of detachment from a hypothetical break and also the gravity acting on it. We can simply understand that if we just assume that the detachment would progress equally on all the sides from a retinal break, then it should lie somewhere where this concavity points out to. So this would be a near center for this, so the break should be here. But keeping in mind the second issue, that there should be a gravity also which is playing role here, so this break would have, this retina would have detached more progressively in the inferior half, and so we can predict that the break should be here, somewhere here in the superior part. So this is going to be the most likely position, slightly above the point where this concavity would converge. So this is about detachments when you have just a quadrant involved. So it will go up to the second circle only, and this is our detached area. So this arm of the retina in the temporal part is higher than the nasal part. So if we presume that the break location is right at 6 o'clock, then this should not happen, that there shouldn't be any asymmetry over these two areas. Rather it should have been flat like a horizontal meniscus. But because it is higher, we can also understand that this should be because the break is onto the side where this is higher. Because going by the rule of radial dissection which we had talked about, this dissection would have continued little faster, or rather the symmetry would have predicted that it would lie at a point which is equidistant from all these points because it has traveled radially. So here we can see that it should lie on that side where the level of contour or the margin of the detachment is on a higher side. So we should be looking for retinal break somewhere here. So this is the portion of the retina which is detached here, and again looking back at the contour, we should decide that this is the border of the detachment on the nasal part and this is the border of the detachment on the temporal part. And as we can again predict that the progression aided by the gravity would allow this fluid to seep radially from the break into the subretinal space, and because aided by the gravity it would have progressed faster onto the inferior part. So at break which would lie here, let's use the correct color coding, would have progressed radially from the site of break in all the directions, and then once it would have reached to the horizontal level somewhere here, then the gravity aid would stop because then again it has to rise up, and same goes for this side. So gravity would work only up till the point where the retinal detachment is still at the level of retinal break. The moment it rises up, then we have just single one rule of radial dissection. So in that scenario we can understand that at this moment when the patient is present, it is always on the higher side of the retinal detachment. So we can predict that because this is the higher side on the temporal and this is the lower side, so the break should lie onto the temporal half. One thing more which helps in deciding the location of break is the height of the detachment. So for that we can make use of this particular section, vertical section, and if we find that the retina is very bullous detached, then that predicts the break has to be on a meridian which is, or the location which is higher than the horizontal meridian or the line bisecting the 3 o'clock and 9 o'clock, because a location of break here on a higher side would allow seepage of fluid and stagnation which will cause a bullous detachment. On the other hand, if we have an inferior break like this, and more so especially for holes and dialysis, the fluid has to rise against the gravity, so it is slow and it will never become bullous. So it is usually a shallow detachment like this instead of being bullous detachment. So just revising what we had learned yet is, number one is radial dissection, number two was gravity, number three was a very simple observation that the break in detachment less than a quadrant would be lying at the focus of the concavity formed by the detached retina. Number 4 is, if you have more than half, then the break is going to be on the higher side, provided that there is a asymmetry. Number 5, the rule would be that if it is bullous, then it has to be above the horizontal meridian, and if it is shallow, then it is below the horizontal meridian. So if we can remember all these 5 rules, most of the times we should be able to predict the location of a retinal break in a case of retinal detachment. One thing more which I want to add here is that usually retinal breaks which are atrophic holes will have slow progression and may not be so bullous at presentation. And a flap tear in any shape, whether it is tongue shaped, whether it is arrowhead, whether it is V shaped or horseshoe shaped tear, these all will have a larger amount of SRF collected, so they will usually present earlier with bullous detachment. So I hope this helps all of us. Thank you.